Hello, my friends. In this video, we're going to talk about circles. Not so much the easy stuff like circumference and area, although you do need to know that, but the circle formula. That is, how to represent a circle using a formula on a graph. Ready? Let's jump right into it. So how do we mathematically express the shape of a circle on a graph? Well, just like expressing any other shape, we have to use a function or formula. This formula is x minus h squared plus y minus k squared equals r squared. Now, if this looks complicated, don't worry, I'll break it down for you. First, let's talk about what each variable represents, starting with the h and k. The points hk represents the origin or center of the circle. So, from there, we can select any point on the circle and that will be represented by x and y. You can pick a point here, here, or even here. Either way, it will be represented by x and y. Lastly, as you know, what makes a circle is when you pick any point on the circle and it will always be a radius length away from the center. Therefore, you've guessed it, the r in the formula stands for the length of the radius. So now that you know what the variables represent, let's take a look at how they are arranged in the formula and what that means. Don't worry, this part is super easy to remember. Let's start off with a plain old circle. Then we have the origin of the circle here. After that, we'll go r units out and we'll have the xy coordinate here. With me so far? Good. Now, I have a question for you. How do we represent the length of r? Meaning, if you're given 2 points, how do you find the distance of the 2 points on a graph? Well, you use the distance formula, right? That is exactly what we are doing here. So the distance formula is d equals the square root of x2 minus x1 squared plus y2 minus y1 squared. But instead of calling it d for distance, isn't that just the r? And instead of calling it x1 and x2, let's call it x and h. Lastly, instead of calling it y1 and y2, let's call it… Exactly, y and k. r equals the square root of x minus h squared plus y minus k squared. Now, we don't really like the square root. It makes it look complicated. So how do we get rid of a square root? Square both sides, of course. So, at long last, you're left with the original circle formula. R squared equals x minus h squared plus y minus k squared. Easy, right? Fun fact, the distance formula is also just the Pythagorean theorem. Because we are just looking for the distance between 2 points or the hypotenuse of a right triangle. Therefore, you can memorize the circle formula as also just the Pythagorean theorem. Do you see the similarities? There you have it. That is the circle formula. But let's see how the test will present these problems. They won't make you do anything too crazy. They just want to know if you can recognize a circle formula and the components of it. For example, let's try this problem together. In the standard xy coordinate plane, the center of the circle shown below lies on the y-axis at y equals 3. If the circle is also tangent to the x-axis, then what is the equation of the circle? So here, you'll notice that the problem is describing a circle. You should then be able to identify the topic of this problem as a circle formula. They were even nice enough to provide a sketch of the circle in question. Once we know it is a circle formula problem, we need to identify the variables. What is your r, hk, and xy? Well, your r is clearly 3, and they gave you the hk to be 0, 3. After skimming the answer choices, you see that you don't even need to know the xy as they kept them as variables. So now we just need to match the formula. R squared equals x minus h squared plus y minus k squared. First, everything needs to equal r squared. So 3 squared is 9. Go ahead and cross out any answer choice that does not have 9 on one side of the equal sign. So we are left with answer choice B, C, and E. Next, we know that h is 0, so get rid of any answer choice that doesn't have x minus 0. So now we are left with B and C. Lastly, we know that the circle formula is just the Pythagorean theorem, and it is a squared plus b squared, not a squared minus b squared. So we can get rid of C as an answer choice. We are then left with B as the correct answer. Voila! Didn't that hard-looking problem turn out to be super easy? Now you try this one on your own. Which of the following is an equation of a circle in the xy plane with center 0, 4 and a radius with endpoint 4 over 3, 5? Okay, if you chose A, then great job. If not, no worries. Let's go over it together. First, we need to identify the variables as much as possible. Our hk is 0, 4, and our xy is 4 over 3, 5. We don't have the r this time, and we also don't have a sketch of the circle. We probably don't even need one, and we can solve this just by looking at it. So, by plugging in the variables into the circle formula, we get 4 over 3 minus 0 squared plus 5 minus 4 squared is equal to r squared. Looking at the answer choices, let's cross out anything that doesn't match. Well, it's y minus 4, right? So we can cross out B and C. We are then left with A or D. We know that we need to square r, so therefore the answer cannot be D since the r is smaller than 1. So the answer must be A. This is how I would solve it on the test, but let's say we want to prove it. Then we can go back to solving for r squared after plugging everything in. So we end up getting r squared is equal to 25 over 9, which matches answer choice A. Alright, today we learned what the circle formula is, the variable components of the formula, and how to identify and solve these types of problems. Remember, if you know the Pythagorean theorem or the distance formula, then you already know the circle formula. I hope you have a wonderful rest of your day, and I'll see you in the next video.